Now, find the inverse of the function f of x equal to minus 5 over 3x minus 5. Then graph the function and its inverse. So here you have to take care. We have to find the inverse and we have to graph the two graphs, the function and its inverse. First of all, f of x is equal to this. So we write it, f of x, which is y equals to minus 5 over 3x minus 5. Remember, we have to find x in terms of y, and then we flip it, okay? How to find x in terms of y? So we bring everything to the other side and keep x alone. So here we have x here, we have minus 5, so we add 5 on both sides. So once you add 5 on both sides of the equation, so we get y plus 5 is equal to minus 5 over 3 minus 5 over 3x. We get rid of this, okay? Now, we have to find x alone. So here we have minus 5 over 3. So to get rid of minus 5 over 3, we divide both sides by minus 5 over 3. But, like the easy way, we can multiply both sides by 3 over 5. You see 5 over 3 here? Okay, to get 1, so multiply by 3 over 5. And don't forget the minus sign. So we multiplied both sides of the equation by minus 3 over 5. Okay? So you get minus 3 into y plus 5 over 5. You see minus 3 over 5 here multiplied by y plus 5 is equal minus 3 over 5 times minus 5 over 3. You get plus 3 by 3 cancel, 5 by 5 cancel. So their product is equal to 1. So you get 1x. Now we have x is equal to this. So we can simplify it. Okay? Or we can write directly. This is x. This is y. As we remember, we have to switch between x and y. But the best or the better representation, because they are asking for the inverse, so we write instead of x, f inverse of x is equal. Now we simplify this. How do we simplify it? Minus 3 over 5 times y, you get minus 3 over 5y. And what did we agree for y? We change it to be x. So we have to change this to be x. So this would be x. Minus 3 over 5 times 5. Minus 3 over 5 times 5, you get minus 3. I'll show you minus 3 over 5 times 5. You know that 5 and 5 cancel, you get minus 3. Okay, so you get minus 3. Now this is the inverse function, and this is the main function, and we have to graph them on the same grid. Now, how do we graph them? Like the easy way that we can do, okay, since they didn't say take points, we can take particular points and graph it. But we learned before, how do we graph straight lines? By using the y-intercept, and we use the slope, okay, which is rise over run. Perfect. So, first, we look at the main function. This is the main function. Where is the y-intercept? The y-intercept is when x is equal to 0. So, this is 0, so you get minus 5. So, 0 minus 5. 0, minus 1, minus 2, minus 3, minus 4, minus 5. This is the first point we need. Now, we start from this point and we look at the slope of the line. The slope of the line is minus 5 over 3. Okay, so you have to go down 5 units and then we go right 3 units. So here it's really impossible because we don't have space. So we can flip the signs. So we can, instead of do minus 5 units down and 3 units up, so give the minus sign for the 3. Yeah, so we make 5 units up and we give the sign for 3. So you get minus 3, so you move left 3 units. So 5 units up. So we move from this point 1, 2, 3, 4, 5. Okay, and then we have minus 3, so we go left 1, 2, 3. So it's same, by the way. If you go down 5 units, minus 5 units, you see minus 5. If you give the minus for the 5 and you go down 5, and then you have to go right 3. So go down 5 and go right 3, you'll find that they are lying on the same line. So here is the line. Which line is that? This is the function, right? The main function. Okay, now we have to graph the inverse. So we can write here, this is f of x, just to differentiate between the two lines. Now for the other one, we have f inverse of x is equal to minus 3 over 5 minus 3. Now, what's the y-intercept? It's minus 3. So let's put at minus 3 here, and we put a point. Okay? Now this is minus 3. Now we have minus the 3 over 5 as a slope. So we have to go down minus 3 units, and we have to go right 5 units. So if we move from here, 1, 2, 3 units, and we go right 1, 2, 3, 4, 5. Let's put the point here, approximately, okay? And let's do the other one. Let's give the minus sign for the 5. So it becomes 3 over minus 5. So we move up 3 units, 5 units left. From this point, up 3 units, 1, 2, 3 units. And then 5 to the left, 1, 2, 3, 4, 5. So this would be the point. Now look at this and that. They belong to the same straight lines, which means that if you draw in this way or that way, both work. So we join the points now, and here is the inverse. Okay? Okay, now, if f of x equal x squared minus 3x plus 5 and g of x is equal 4x minus 5x squared minus 1, what is f plus g of 1? Now, f plus g of 1, let's just ignore 1 now, okay? Let's just as hide it, okay? Like hide the 1. And let's do f plus g. So if we add f plus g first, okay? So f plus g, f of x plus g of x is equal to what? Let's add the two functions. X squared minus 5x squared. Now you can put them beside each other if you want, okay? Or you can start from here. X squared and x squared, x and x, number constant and number constant, okay? And find the answer. Now if you want to put them all together, you can put them all together. Like x squared minus 3x plus 5 plus 4x minus 5x squared minus 1. Remember, if they say f minus g, so you have to put all of this in bracket because the minus sign outside would reflect on all signs inside the bracket, okay? So take care of this. When you use minus sign, it's different than when we add. Now, we are adding, it's equal x squared minus 5x squared, you get minus 4x squared. Minus 3x plus 4x is equal to plus 1x. Okay? This is cancelled. 5 and minus 1, you get plus 4. So now this is the sum of the two functions. Now they want you to find f plus g of 1. Okay? So we say f plus g of 1 is equal. We take this function, the final one, and we replace 1 instead of x. So we say minus 4 into 1 squared plus 1 into 1 plus 4 is equal to 1 squared is 1 times minus 4. This is minus 4. 1 times 1 is 1 plus 4. So we get plus 4 minus 4 cancel, which is 0. Then we end by 1. So the final answer is 1. So this is 1 correct. Okay? And then that's the final answer. Yeah. Which expression represents f of g of x if f of x is equal to x squared plus 3 and g of x is equal to minus x plus 1? Now, they said f of g. They didn't say f of g of 2, f of g of minus 1. They didn't mention. This is just f of g. Okay? So, we can say f of g is f of g. What is g? It's minus x plus 1. This is minus x plus 1. It's equal to, so f of minus x plus 1, we go for the f function. And instead of every x, we replace it by minus x plus 1. Okay? So, as a systematic, like you do it easily. You say it's equal to, go for the f function. This is the f of x. Each x you see, put it in bracket. Okay, so we have x squared, so we have bracket squared. Plus 3, that's plus 3. And then go back into the function and look inside. What's here? Look, here we have x. Okay, that's why it was x squared plus 3. Here we have minus x plus 1. So go for the bracket and replace it by minus x plus 1. Now we have this form. Now, moving from this form forward, we look. What operations do we have? We do. We have simplification, we simplify. We have square, we do square. We have radical, we do radical. Whatever you have inside, you apply it. Now we have square. So we do quantity square, which is binomial square. How do we do binomial square? We do square of the first, 2 times first and second, and then second square. So squaring of the first, minus x all squared, it's minus x all squared. Let's leave it like that. Now, what's the sign here? Plus. We say plus 2 multiplied by the first, which is minus x, multiplied by the second, which is 1. And then finally plus the second square, which is 1 squared. And we don't forget that we have also plus 3. Okay? So now we simplify. It's equal to minus x squared. Minus squared is plus, and x squared is x squared. Now, 2 times minus x times 1. 2 times minus 1, which is minus 2, times 1, minus 2, and then we have x2. So, plus 1 squared is 1. Plus 3, 4. So, it's plus 4. Let's compare the answers. We have x squared minus 2x plus 4. So, that's the proper answer. So, this is correct. Okay? Yeah. If f of x is equal to x cubed plus 1, find f round f of 2. So in this case, when they enter a number into the composite functions, so you can do the function of the value first and then do the main one. Like if they ask you f round f of 2. So find f of 2 first and then do f of the answer you get. Or you can find f round f generally, as we saw in the previous exercise, okay, and then replace 2 in the other function, which is more complicated, okay? Easier, start by the number first. Look, f round f of 2, what does it mean? It means that it's f of 2, okay? So find f of 2 first, get it a number, and replace it inside. F of 2, let's do it beside. F of 2 is equal to, we have the function x cubed plus 2, so replace 2 instead of x. Yes, you get 2 cubed plus 1. 2 cubed is 2 times 2 times 2, which is 8, plus 1 is 9. Now, f of 2, all it's equal to 9, so we can go for f of 2 here and replace it by 9. It's equal to f of 9, which is equal to, now f of 9, which is 9 cubed plus 1, which is equal to 9 cubed plus 1, which is equal. Now look at this. This is, we solve it usually in SAT questions. Okay? In SAT questions, sometimes they don't give you more time. Like each question should be 1 minute or 1.5 minutes maximum. Okay? So we want to calculate 9 cubed plus 1 to find which one fits with the answers. Okay, so I know that 9 cubed is 9 times 9 times 9. Plus 1. So 9 times 9 is 81. Times 9 is more than 81. Okay, so it's going to be like 100. Okay, so which one of these fits the answer? Because one of them is true. So this would be the answer. Okay, so it could be 730. This is cancelled, this is cancelled, this is cancelled. We know that 9 times 9 times 9 is greater than 82. So that's why we choose this without calculating 9 cubed. This question looks more complicated than the other questions. Okay, but for the first glance, like when you look at the question, you think that it's complicated. But when you move forward, you find that it's easy. Okay, because you know the concept, you know the rules, and then you can apply it. So they said f round g of 4. Let's write this in the form that we used to use it. Okay, f round g of 4, it's f of g of 4. That's the proper way we use, right? It's equal to. Now, g of 4. Let's go for g and replace 4 instead of x. So, g of 4 is equal to 9 over 2 radical 4 minus 1. Okay? It's equal to 9 over radical 4, 2 times 2, 4 minus 1, 3. So you get 9 over 3. But what about 9 over 3? 9 over 3 is equal to 3. Very good. So you see now it becomes more easier and more simple. So g of 4 is 3. We go for g of 4 and we represent it by 3. It's equal to f of 3, which is equal to, let's go for the f and replace x by 3. So you get 4 over 3 plus 2, which is equal 4 over 5. Okay? Good. Resume. What is the domain of the function f of x equals to radical x plus 4? Let's see this. Now we know that we have two cases we studied till now, or like mainly three cases or four cases, but two of them that are similar. When we have a linear function like y equal 2x plus 5, this is a line. Okay, so linear function, the domain of this function is set R. Set R, set of all real numbers. All real numbers you can replace it, okay, by x. Like x you can replace it by all real numbers. Y, any value replace x by, you get y value. Okay, this is a linear function. Polynomial function or second degree or third degree function, okay, like y equal x squared plus, let's say, 2x plus 7. This is a polynomial function. Also, you can replace any value for x to get y. So also this, the domain is set R. So here, domain is set R, all real numbers. Here, similar, its domain is set R. Okay? The problem we face usually is in some functions, there are some values you cannot replace. Let me show you why. You know that radical of negative is impossible in set R. Okay? In set of real numbers, radical negative, it's impossible. Now, to start guessing, since x plus 4 is a simple expression, we can guess. Like, can you give me a value for x so that when you add it to 4, you get negative number?
5.
Negative 5. Negative 5 plus 4 is negative 1. Radical negative 1, in set R, no answer. There's no value. It's impossible. Okay? So, it means that minus 5 does not belong to the domain. Okay? So, shall we keep trying numbers? If we keep trying numbers, you tell me like minus 4.5. If you say this, I can tell you minus 4.2. You can say, yes, I can tell you minus 4.1, minus 4.05, minus 4.000001. When you add it to 4, you get minus 0.00001. So all of them you get negative. So the best way, okay, to solve this, to find the domain, take a condition, make a rule for yourself. Say, x plus 4 should be greater than or equal to 0. Now, greater than or equal. Okay, greater than, we got it. Y equal. So let's try. If x plus 4 is equal to 0, if x plus 4 is equal to 0, Amar, okay? Radical 0 is what? 0. So we have value. But radical negative, there's no value. So we have restrictions here. X plus 4 should be greater than or equal to 0. Okay? So, since x plus 4 should be greater than or equal to 0, this is an inequality. Inequality could be solved like equations, but with some restrictions, like when we have negative multiplied by x, we should take care. If you divide by negative, you should flip the sign. Okay? But as solving, we follow similar procedure as we solve equations. How do we solve it? We have plus 4 here, take it to the other side. Or you say minus 4 here, minus 4 there. So you say x is greater than or equal to negative 4. Okay, so x is greater than or equal to negative 4. This is the domain. Domain means that the value that you are allowed to represent in this function, replace it with x, okay, or replace x by, should be greater than or equal to negative 4. What do you mean by greater than or equal to negative 4? Don't forget, when we move for greater in negative, so we say we move towards 0. Don't say minus 5. Minus 5 is not greater than or equal to minus 4. Minus 5 is smaller than minus 4. Okay? So we say, let's say minus 4. We start by minus 4. And then minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. All of these numbers are greater than minus 4. Okay? Like minus 4 also greater than or equal, so minus 4 is included, and then we move forward. Okay? So the domain of this function is x greater than or equal to minus 4, which is correct here. Okay? Perfect. Now, the restriction, more restriction that you ask me, why do we use greater than or equal and not greater than, or when do we use that? Yes, good question. Let me show you. Suppose that this function, like that, okay, it includes radical x plus 4, but it's not in the numerator, it's in the denominator. Let's say we have 2 here, like 2 over this. Good. Here we have 2 restrictions. First one is inside radical. Inside radical should be positive, as we said here. So we say x plus 4 should be greater than or equal to 0. Starting here. This is the first thing for radical. Now, the second restriction is we have this radical sign in the denominator. So if we say x plus 4 greater than or equal to 0, okay, so if I take the equal to 0, number over 0 is undefined. So we have to cancel the equal here. So it's only just greater than 0. Okay? So equal, because it's in the denominator, it's not accepted. 0 in the denominator, we can't find the division. 2 over 0, undefined. 5 over 0, undefined. 7 over 0, 100 over 0. Okay? It's undefined. And we are looking for the values that we replace it in the function to make it defined. The domain is a set of numbers that replaced in the function that makes the function defined. Okay? This is domain of definition. It's called domain, but it's not complete. It's called domain of definition, which means the values for x that make the function defined. Got it? Okay.